Recall that slope is rise over run, or the vertical change over the horizontal change. In number 1, if we look at explaining how to count each of the following slopes, we want to look at them as a fraction, as rise over run. So if we have a slope of 3, that's not a fraction the way it's written. But what we can do is put it over 1 like that to make it a fraction. So that'll tell us the rise is 3 and the run is 1. So the way we count that is we go up 3 and to the right 1. For a slope of -2, similar to that first one, it's not a fraction yet, so we can't look at rise over run until we make it a fraction by dividing by 1. So that means a rise of -2 means we go down 2 and to the right 1. The next one is fairly obvious, a slope of 2/5, up 2 to the right 5. The next one is one of the trickiest ones. When a slope is a negative, in this case 4/3, remember to get a negative answer, that's either a negative divided by positive or positive divided by negative. So you can look at this as -4 divided by +3. That would give you a -4/3 when you simplified it. So if you look at it that way, that will be down 4 and to the right 3. So the point there is when you see that negative, you put it in the numerator or the denominator. I always say numerator just to keep it the same every time. Put the negative in the numerator, and then when you count it, you're always going to go down and to the right. So in this case, down 4 to the right 3. The reason that negative doesn't go with both the 4 and the 3, if you were to write -4 over -3, what is a negative divided by negative? It'd be a positive 4/3, which is not the same thing as a -4/3. That'd be like saying +2 is the same thing as -2, and it's not. And then finally, the last one, a slope of 1/3 means you go up 1 to the right 3. So that's how you count slopes. You want to think about it as a fraction, as rise over run, and just be careful when you have a negative slope. Put the negative in the numerator, not the numerator and the denominator. Okay, it's one or the other, but not both. Okay, so number 2, graph the lines with the given slope and passing through the given point. So we want to graph a line with a slope of 1/2, which means we're going to count up 1 to the right 2, and it has to pass through the point 0, -5. So what you have to do first is you have to plot the point first. Because if you count up 1 to the right 2, you could start anywhere on the graph and count up 1 to the right 2. But to go specifically through that point, I would suggest that you start at that point 0, -5. So down here. And then from that point, count up 1 to the right 2. So keep counting up 1 to the right 2. And I will say, again, notice that to stay on that line, if you went from any point on the line, down 1, left 2, so switch both directions, then that'll keep you on the line. So up 1, right 2, same as going down 1, left 2. That's changing both directions. So you would plot those points, connect them with a line when using a ruler, and there's your graph. So if you try the last 2 here, again, remember that the -3/2, treat that as -3 over +2. Okay, so pause the video and try those 2, and then I'll put the answers up. Okay, so when you're all done, this is what the graph should look like. So in the second one, we started at 0, 3, and then went up 2 and to the right 5. Same as going down 2 and left 5. And then on the last one, a slope of negative 3/2, down 3, right 2, and we start at 0, 6. So we start up here at 0, 6, and down 3 and to the right 2. Down 3 to the right 2. Okay, at the bottom of the page, we have a linear relationship if the slope remains constant. So in that first example, notice as you count up 1 and to the right 2 several times, you form a line. Also note that you may also count any ratio equivalent to 1 over 2, or 1/2, and still be on the line. So negative 2 over negative 4, we could count down 2 to the left 4. Negative 1 over negative 2, we could count down 1 to the left 2. Okay, and if I show you that again, we started at 0, negative 5. And again, what this is telling us is when we count up 1 to the right 2, we could have also gone down 1 to the left 2. That's what this is. If we count down 2 and then to the left 4, that's what negative 2 over negative 4 is. If we counted up 4 to the right 8, so 1, 2, 3, 4, and then to the right 8, that would take us to this point right here, which would be on the line. Okay, so that'd be 4 divided by 8. So that's what it means is any ratio equivalent to 1/2, as long as you count that, then you'll stay on the line. So on the second page, graph the line with the given slope passing through the given point. So now negative 5, negative 1 with the slope of 2. So this is similar to the last page. We start at negative 5, negative 1, so we start at this point. And the slope of 2, remember that's like 2 over 1. So you go up 2 to the right 1. Up 2 to the right 1. Now notice that's the same as going up 4 to the right 2. So 4 divided by 2 would also be 2. Okay, then you take a ruler, connect them, and I will show you, pause the video and I'll show you the answer key for those. So this is what those will look like. Again, the negative 2/5 in the second one, those negative slopes are always the toughest. You count down 2 and to the right 5. So we start at the point 2, 3 and count down 2 to the right 5. Or we can go up 2, left 5. So that's how you plot a line given a slope and a point that it passes through.